everybody, today we will see yield stability analysis using AMMI method. AMMI means it is additive and multiplicative interactive analysis, and yield is highly dependent on genetic and environmental factors in which the interaction between the genotype and the environment reduce the association between the phenotypic as well as the genotypic component. For a long time, J-by interaction has been the primary term in plant breeding because it assesses breeder in variety selection. So it is a determination of which variety should be recommended for the benefit of mass or for the farmer. So several statistical methods have been coined to characterize and minimize the effect of genotype by environment interaction, especially in the selected variety, and also to predict a phenotypic response to environmental change. However, most of statistical stability methods are not able to provide accurate and complete variety response pattern. Especially regarding to their J by interaction, especially because the genotype to environmental variation is mostly it is multivariate, while most of the stability indices have a univariate response. For example, if you take ANOVA, it is an additive model in which the J-by interaction is a source of variation, but its intrinsic effects are not analyzed. If you compare and contrast the ANOVA with the PCA or the principal component analysis, it is a multiplicative model and therefore doesn't tell you anything about the main effect for the environment nor the genotype. However, this model, that means the additive and multiplicative interactive analysis, it includes both ANOVA and PCA in a unified approach that can be used to analyze multiple yield trails. So this method, or the additive and multiplicative interactive, use ANOVA. One, it is to test the main effect of the genotype and environment, while the second one, that means the principal component analysis, it helps to analyze the residual multiplicative interaction between the genotype and the environment in order to determine the sum square of the J by E interaction with a reduced or with a minimum number of degree of freedom, because ANOVA and PCA are a part of this model, so it is AMMI is likely more suitable for the characterizing the J by E interaction. So coming to the popular use or the popular benefit of AMMI is it is used wisely in the stability analysis because one, it provides initial diagnosis of the model, and as well it is well suited for data analysis with many environmental influences. The second reason is it allows greater unfolding of their J by E interaction and summarize the pattern and the relationship between the genotype and the environment. The last importance, or the last widely acceptance of AMMI is it improves the accuracy of trait estimates. So this is all about the definitions of the additive, main, and multiplicative interactive analysis. So today, for this sake of tutorial, we use the library Metan to get the data. So you have to load on your RStudio. Then from Metan package, there are different data that's available. So for sake of tutorial, we will use data genotype for our example. So let me show the data look like. So let's see here. It contains different environment. For example, if you want the detail about the data type or data, so type data, and here is JE and RAM. It will give you detailed information. As I think here is a multi-environment trial of odds. So the dataset contains two variables assessed in 10 genotypes growing in different 11 environments. I think this should be 14 because if we view our data, if you view our data, let me write our data name. It's data GE. If you write, if you view our data, let's see, stating it contains, sorry, there is no view. Okay, if it's so, let me show the tail of our data. Let's show you the last 6. So here is the environment is 14. I think this should be corrected into 14. So, and again, the method is random complete block design. The replication is 3 and having also 10 genotypes. So by this way you can check further your data type, your data structure. And then again, if you go further for analysis, you have to use, there are different types of stability analysis. One is ANOVA, there is a PCA, there is a regression based. So today we will see the additive, mean and multiplicative interaction analysis. So to do that, you have to type AMMI module, then performance, the AMMI, and write here is your data name, here the environment in capital, or on your it should be similar with your data. Then here is the genotype, there is the replication, here is the grain yield. So type this one and run. So it will show you some result over here. Let me maximize it. So as you see here, there is AMMI analysis table. The source of variation is environment. Here is application. There is genotype and genotype by environmental interaction. There is 9 principal component analysis. Here is the degree of freedom, and if you see here is the sum square is around 279.574, and the total sum square is 389.036. So this means that around 71%, if you divide 279.574 to that of 389.061, you will get 71% of the variation for the genotype comes from what? From the environment. So you can even also calculate 31.22 divided by 38906 is around 8% variation that comes explained by genotype and environment. So chiefly environment is highly affected the genotype. So by this way you can also you can do your stability analysis, and furthermore you can also use the other method. That means here is we are using to test the stability analysis AMI model, but if you want to convert this one, the WAS method also shows a similar result to that of the previous one. That means the AMMI or the performance AMMI. You can use either this one or this one. Both will yield the same result. So type this one on your data or data name. There is environment, there is genotype, replication, grain yield, and this the verbose is say false. Then type this one, and again lastly run. So by this way you can get your similar result to that of one. For example, here let me maximize it. Yeah, the first one already is 279. Here also we get 279 compared to the previous one. So you can use the was function or the AMMI method. So both will yield the same result. So if you want to draw the bioplot, you have to use a function plot underscores. So again, you can draw two different bioplots. The first one is the additive effects versus the interaction of principal component analysis. Maybe you have 20 genotypes or 40, depending on your data. So it will compare the additive effect as well as the interaction of principal component analysis. So to do that, you have to give any names that you want here. Let's say for simplification A and plot underscores. Then the model one is this one, which is given here. So if you want to perform that, do the AMMI model 1, the name that you give here. Maybe you give here your name, maybe you give anything that you want here. So it doesn't bother or doesn't create any problem. So type this one and run. So let's see the plot look like. Let me zoom out. So let me zoom in. As you hear is around 14 different environments. The environment which lies on the green and the blue one is the genotype. So the more close to the origin, for example, genotype G6, G3, and here also G2 are very stable comparing to G8 or G9 or even here G10. So the more closest to the origin are the more stable genotype. So by this way you can check the yield against the interaction of principal component analysis. The other one, if you want to beautify more and more, you can add the following syntax. For example, your type any name that you want, let's say D, then as this is a function, the plot underscores, then the model type, the model name that we give before. Here is, yeah, so in model 1, so type it, and you can give, for example, color, it is red, and for genotype, color for genotype is red, color for the environment is green, color and for the segmented environment is blue. I think this is the line that will show you. So it is blue. By this way, you can type all this one and run. Then here also the name that we give here is D. So plot D. So let me see. Yes. So the genotype is marked or represented by red color, while here also the environment is represented by green, and the segment is and again represented by blue line. So based on your color preference, you can beautify on the way that you want. And again also the second one is, that I mentioned before, it is the Bioplot for the two axis for the two axis interaction. That means here is, let me correct it. Axis interaction, that means principal component analysis 1 versus principal component analysis 2, and it will yield this. The first one is the AMMI1, but here will give you the AMM2. So to do that, you give any name that you want here, then plots underscores, then the model, then type is equals to 2. That means it will yield in place of 1, 2. So type this one and let's run. So by this way it can gives you detailed information. For example, in this case G3, I think it is G3, then G1, and again also G2 is more stable. But in the previous
in the previous one, if you remember, in the previous one, it is here is G3, G8, and G4. So mostly I recommend you to refer the second one, because it will compare and contrast. It is the interaction effect, both the principal component analysis 1 and principal component analysis 2. So, and again, if you want to further amend, you have to type this one. You can give any name that you want. So write the syntax, and also you can modify your bioplot analysis in this way. Then type this one and run. So by this way you can have different bioplot graphs that you want. So what I want to stress here is you have to better to select the AMMI tool method, because it uses both the principal component analysis for both PCA1 and PCA2. So if in case the first one is it show maybe G3, G1, and maybe G10, but here is G8, so you have to select this one because it contain both the PCA1 as well as the PCA2. So thank you for watching, and as usual, if you have any question regarding to my tutorial, you can address me through this mail, wagjiratesfound@gmail.com. So have a nice time. Goodbye.